Today I'll be deriving the formula of an ellipse from its definition. And its definition is something like if there's two lines like this that have constant length, when you sum those lines, it will create an ellipse. Alright, so let's first name our distances. So from here to here, let's name this A, or the major axis is A. From here to here is B. And then from here to here, the focus from here to here would be C. Alright. And alright. Now let's try to find the length of these two lines. What would the length of these two lines be? Consider a case where we're considering this point and the lines are overlapped, or only overlapped at a small section. So there's an overlap here. Okay, I'll draw a second line just to show you that there's an overlap. Okay, because as you see here, as this point approaches here, these two lines will overlap. Now, I want to find the length of these two lines. Well, the length from here to here is just C. The length from here to here is also C. Then what would the length from here to here be? Well, if this is A and that's C, then this length here would be A minus C. So the total length would be C plus twice, because there's overlap here. A minus C, which just ends up being 2A. So 2A is the length of the sum of these two lines. Okay, now let's use this formula and that the length of two lines equal 2A. And let's consider a case where instead of them overlapping over there, the lines are over here. Okay, that's poorly drawn, but okay. So the height is B, the base of C. Now we can use Pythagorean theorem. So A, or let me just write 2A, the total length equals two of these lines. So from here to here, that's two lines times, what is the distance from here to here? Well, that's just B squared plus C squared root. So root B squared plus C squared. Okay. Oh, poorly drawn, but okay. Now we get that A equals root B squared plus C squared. And finally, we get that A squared equal B squared plus C squared. Hopefully you know what we did there. We found the length of these two lines to be 2A, and we know, and the definition of an ellipse has the length of these two lines to be constant. So after we found that the two lines have a length of 2A, then we try to derive another expression for the length of these two lines, and we got another expression would be 2 times root B squared plus C squared, and then we get from here to here, A squared equal B squared plus C squared. Okay, now we can get to the heart of the proof, or if you want to call it that. Let's consider, now we want to find the length of the two lines in terms of X and Y. So this is poorly drawn, but okay. So from here to here, distance from here to here is C, and then this distance from here to here is X. Hopefully you know why. B, because we're considering this point right here. And Y would be from here to here. That would be Y. And B is just slightly taller than Y. Yeah, this is a poorly drawn ellipse, but hopefully you get the idea. Now, we know the length of the two lines equal 2A. But now we're trying to find the length of the two lines in terms of Y and X. So in order to do that, we have to use Pythagorean theorem. So what is the length of this line from here to here? Well, we can use Pythagorean theorem, and it would be root Y squared, because Y squared is height. And then the base would be C minus X squared. Because C minus X is the length of the base. If this is C and this is X, then from here to here would be C minus X. Plus, what is the length of this line from here to here? Well, its height is still going to be Y squared. The height of this triangle will still be Y squared, plus its base, which would be C plus X squared. Alright? Because from here to here is C, from here to here is X. So that means the length of this from here to here would be C plus X squared. And the length of these two lines would equal the sum of these two expressions. Alright, now let's move this to the left side so we can, do some easier calculations, but it's still a pretty lengthy calculation. And let's square both sides. So we get 4a squared minus, I'm just going to square this first, y squared plus c minus x squared minus 4a y squared plus c minus x squared equals y squared plus c plus x squared. And something you should, whoops, the squared should be out here. Yeah, something you should notice here is that y squared and y squared, they cancel out. So then we get, and let me expand this. 4a plus c squared plus x squared minus 2cx minus 4a y squared plus c minus x squared. Let me expand this side too. And look, we have more terms that cancel out. So this cancels out, this cancels out, this cancels out, this cancels out. So 4a, let's bring this to the left side here. So negative 4cx equals, let's bring this to the right side. 4a y squared plus c minus x squared. Let's divide each side by 4a. We get that 1 minus cx over a equal, and then let's square both sides. Okay, we square both sides, and let me think. Oh, rip, this should be a 4a squared. Sorry about that. So when we square both sides, this becomes 4a squared, this becomes 4a squared, and this becomes a. All right? Because we squared both sides here, we get 4a squared. This just gets its root removed. Then we multiply this to this and times 2, we get that. Okay, and now we divided 4a on both sides, so we get this. It's easier to calculate. And then we get a squared minus 2cx. We're going to square both sides again. Plus c squared x squared over a squared equal y squared plus, and let's expand this, c squared minus 2cx plus x squared. So a times negative cxa is cx times 2, negative 2cx. All right, let me rip this out. Let me see if anything cancels out. Oh, negative 2cx and negative 2cx cancels out. All right, so then we get a squared plus c squared x squared over a squared equals y squared plus c squared plus x squared. Now, as we said before, a squared equals b squared plus c squared. So let's rewrite this as b squared plus c squared x squared over a squared equal y squared plus c squared plus x squared. And some things cancel out, this and this. Now, let's bring this to the right side. Okay, and what does c squared equal? Well, if a squared equal b squared plus c squared equals a squared minus b squared. And let's plug that in here. So b squared equal y squared plus x squared minus a squared minus b squared x squared over a squared. It just simplifies down to so I distributed and then I multiplied by the negative sign. So a squared over a squared is 1. So we get 1 minus the negative x squared. And then let's divide both sides by b squared. And oh, this just cancels out. So we get that 1 equal y squared over b squared plus x squared over a squared. And the standard formula flips these two, but you get that. Yeah, you get what I mean, all right? So basically, the mathematical argument says proves that derives that from the definition of an ellipse, we get this formula. So you can look at what I've done here in two ways. Either that I proved that an ellipse have this property, because for mathematical proofs like these are converse statements. So if this, then that. Then we can also say if this, then that. Because like we can just work backwards, and then we get to these formulas here. So that would mean that these statements are converses. So we know that ellipses fit this definition, and this definition is only for gets you an ellipse. Okay.